Good morning, everyone. Thanks for joining us this morning. Give me a thumbs up if you can hear me okay. Awesome. This is great. This is not me. This is the next deck, so give me 1 minute while we get this figured out. I mean, it could be me. Grow a little bit of a beard in. 2 minutes, please. Excuse me. Okay, let's try this again. Thumbs up if you can hear me. Great. And this is the right slide, right presentation. So good morning, I'm Mike Kuntz. I'm a Principal Solution Architect with Amazon Web Services. Today we're going to talk about a tale of two pizzas, accelerating software development using AWS tools. So why are we here today? Well, we're going to talk about DevOps. We're going to talk about what it is. We're going to talk about the history of DevOps at Amazon, even going back before AWS. We're going to talk about the tools that you can use within AWS, the AWS Code Services, and the DevOps Portfolio that AWS offers. We see today software moves faster than ever. Every year, Puppet releases a State of the DevOps report. Back in 2017, they looked at it and they saw 5 times lower change failure rates, 440 times faster times from commit to deployment for applications, 46 times more frequent deployments, and then in the survey they also found 44% more time was being spent on actual features and code instead of fixing problems. So what is DevOps? You know, if you're here and you think DevOps is going to be a set of tools or a CI/CD pipeline and it will fix all your woes, that's not what DevOps is. There's not an actual standardized definition. There's lots of different takes on what DevOps is. AWS, we believe it's a combination of cultural philosophies, practices, and tools that increase an organization's ability to deliver applications and services at a high velocity. It's really these cultural philosophies that we start off with when we talk to customers that are looking to move to DevOps. You know, we go in as a solution architect. I don't actually start talking about code commit as the tool that's going to make you get to DevOps. We look at your org chart. We look at how your company or your organization, your enterprise, the industry you're in, how that's shaped, and is it siloed? That's one of the things about DevOps, right? Getting the development teams and the operation teams to come together. No more silos and trying to break those down. Shared responsibility is another key cultural aspect of DevOps. And ownership. Time and time again, we see in industries where we go and we talk to customers where ownership is one of the biggest blockers that they have. You know, the problem, if you've worked in a place, you're probably aware of this, it's not my problem, it's someone else's problem. With DevOps, ownership becomes really important to making it successful. And then visibility and communication. You know, cultures of no or cultures of blame are really difficult in DevOps to implement with DevOps because you want to have open communication. So if there is a fault, if there is a problem, you can openly discuss it and run through best practices. Another common DevOps best practice, microservices. So we see lots of customers moving away from these monolithic applications and architectures into individual microservices. Another common DevOps practice is around continuous integration, continuous delivery, and continuous deployment. And we'll talk about what each of these mean a little bit more in this talk. And then another DevOps practice we see, infrastructure as code. We'll spend some time talking about this today, but it's really one of the powerful parts of the AWS platform where you don't have to go in and point and click or pay people to go rack and stack servers. You can go and use a service like CloudFormation or Terraform and have your entire infrastructure laid out as code. So here's an example where we're going through making some EC2 instances to run and stand up Microsoft Active Directory. And we'll go and we'll save this source file in a code repo, just like our developers would be doing. So you build your servers, you build your infrastructure in code, and you deploy it. So then if you have to go and change environments from dev, test, stage, you have the same source of truth that you can go and make duplicative environments to get you all the way up through promotion of stages. And then monitoring and logging. This is so incredibly important because if you don't know what's broken, you don't know what the problems are, you know, how can you possibly go and troubleshoot? So a common practice where we'll go through and look at are canaries. Multiple, you know, the ideas of a canary goes down a coal chute, dies in case there's, you know, noxious gases, warns people ahead of it. We use the idea of code and canaries where you have a problem that's detected early before it turns into a larger scale issue. Some of the benefits of DevOps, we see improved collaboration, rapid delivery. You're able to go and deliver your tools and your software and your features faster, higher degrees of reliability. Security greatly improves because if you have this immutable infrastructure that is not changeable and you can do drift detection, you don't have the one-offs where some security vulnerabilities may come in at. Scaling is another thing, and then just overall speed for the teams, the developers, the applications. So if we look back at development at Amazon, it started kind of like this. We showed this slide earlier. Monolithic application. So if you went to the Amazon.com retail site back in 2001, it was this huge heavyweight monolithic application and C++ and a bunch of other languages put together, and our team structure looked a lot like the application. You would have to go through to do a change to the shopping cart on the Amazon.com retail site. It might potentially affect the search part of the Amazon.com retail site. And there was this cascading ripple effect of changes that would happen. So as the site became larger, became busier, one single change had a very big blast radius. And we took a look at it and realized that we needed to move to a more of a microservices architecture and decouple all of the individual components of the Amazon.com retail site. So now if you went to the homepage of Amazon.com, there's going to be the search bar, and that's one team. And then the shopping cart is another team. And then the pictures and the images, all the content, those are going to be different teams. And when we were breaking up the services, we realized we had to break up our corporate structure as well. So we had a monolithic application, and we kind of had some monolithic teams. We took our teams and we turned them into what are called two pizza teams. That's what we refer to them internally at Amazon. And the idea is that no team is bigger than what can be fed with two pizzas. And not those, you know, little fancy pizzas that you pay $20 for that have arugula, like a legit New York pizza. Like a team that can be fed by two pizzas. And this started to work out really well because we could go and grow and scale the business at a much faster rate. There's an interesting theory out there, it's called Conway's Law. If you go and look it up, you'll kind of see how he talks about the organizational structure really relates to how you design and develop applications and systems. And we saw this at Amazon, where we had to break up our teams as we were breaking up our services. things went a lot better at this point. The teams were releasing even faster than ever, but we still felt that there were areas where we could improve. So back in 2009, we ran a study to find out where we had inefficiencies, because we had changed the entire system of the development teams and the application, so we wanted to look and see other areas where we could improve. So one of the things we did when we ran this study is we found we were just waiting. A lot of you in the room might be familiar with this flow. So you go and you write some code, and then you sit there and you wait. We had developers that were emailing people to go to the next stage. Then you would build code. They were waiting some more. Then there would be another email notification that might go out to go and deploy it, and another team would come in and do the deployment, and then they were waiting, and then finally there might be a manual approval, and it would be deployed to prod. And this workflow was taking hours or days, and we wanted to go and remove all of these blockers. Everywhere where there was a wait, we wanted to remove that. So what our teams did is built some tools to help automate our software releases and processes. The first one that really came out was pipelines. So if you worked at Amazon, there's actually an internal tool called pipelines. You can go through, and we liked it so much, and our developers like it so much, we actually externalized it, and it's a product called Code Pipeline. So if you go in the AWS console, it is the construct that Amazon is using as well for their development. What these pipelines allow you to go through is take automated actions and go to transition to different states and stages, all the way from checking in code to deploying directly to production. Now, if you're not doing that today, the idea of checking in code and having it deployed in production automatically is terrifying if you've never done this before. And I'm not suggesting everybody leaves and goes and implements that tomorrow. It's a journey. We're going to talk about that journey, how you can get there, how organizations are getting there. But the big benefits you see, again, going faster, improving security, and we saw that it also allowed us to visualize the process of code deployments. It's continued to work really well. Back in 2014, we did 50 million deployments in Amazon that year. Thousands of individual service teams and 2 pizza teams, all building out individual microservices. And they were practicing continuous delivery across dozens of different environments. Every year at Amazon, we go and do a survey of all of our software developers. There's one result we can find that is you can always statistically correlate with happier developers, and it was our pipeline service. We found that continuous delivery made happier developers. We actually have math that can go and prove this out, and we've seen it over time, year and year again. So like I said, the idea of going and deploying code and putting it directly into production could be terrifying. So where do you start? We'll look at the 5 major phases of release and monitor. So in the first stage, you have the source. So this is checking in source code such as .java files, maybe peer reviewing new code. And for infrastructure as code, we talk about this in the same place. So this would be your CloudFormation templates. Maybe these are your container images, definitions that you're putting in. You treat those as source as well. And then when you go to the build phase, this is where you go and compile code. So, it's code that needs a compiler, for example. You'll do unit testing here, style checkers, linters, and create container images here as well. So in the idea of the infrastructure as code piece, this might be where you go and lint your CloudFormation template to make sure everything's working and set up correctly. The test phase, this is where you do the integration tests with your other systems. You perform load testing here, UI tests, security, penetration tests, vulnerability scanning. And then in the deploy phase, this is where you actually go and deploy to your production environments. And then this final phase in monitor, this is where you're monitoring your code in production to quickly detect unusual activities or errors. So we break that down, those phases, and look at the individual release process levels. We can see through source and build, this is where continuous integration is. So we talk a lot about CI/CD pipelines, breaking down what these individual pieces mean. Going all the way from source to production, that's where we look at continuous delivery. And you'll notice there's a gate here. So when we look at continuous delivery, we think of a gating mechanism, manual approval or something there. And then continuous deployment is that idea of checking in code and it's going out to the production. Now mapping those phases to the individual AWS code services that exist. So under source, there's AWS code commit. And I'll go through each of these services in a little bit more detail in this presentation. For the build, there's AWS code build. Testing, this is also, you can use AWS code build, and then there's a host of third-party tools that exist out there. For deployment, this is AWS CodeDeploy. And then in monitoring, that's where X-Ray and Amazon CloudWatch come in. Tying all of this together, this is the pipelines we were talking about. That's AWS Code Pipeline. And then up top, a service we recently launched, AWS CodeStar. It allows you to go through a single pane of glass and build all of this quickly and rapidly. Some other services that exist in the DevOps portfolio, the ones on the left we talked about here, the code/services, CloudFormation for your infrastructure as code, OpsWorks, and then monitoring logging. There's also CloudTrail and Config. And I kind of laugh at this slide. So I'm coming up on 5 years at working in AWS, and it's been a great journey. When I started, we had 12 services, and it was really easy. I could know all 12 services, and I could dive into them. We're over 100 different services. I think today I'll talk about 20 of them. This pace of innovation just continues to go, and when we're looking at that accelerated pace of services and releases, you always want to make sure that you're looking at the AWS services, working with your solution architect and the account team to see what's on the horizon. So if you're an active customer and you're engaging with AWS, you should be checking in on your architecture and your design and your deployments with your AWS team to make sure that there's not a service that might be coming out, a reInvent, for example, or in the next coming months, or a feature that you're trying to build yourself that we're going to release next week. Last year, I think it was over 1,800 individual meaningful features and releases that we went through and released last year. That pace is, if you look at it over the years, is a hockey stick, right? I mean, it's gone from 63 to up to 1,800 and then over. That pace will continue to go as we grow. So we'll take a look at build and test your applications. At this point, AWS Code Build. So this is a fully managed build service. It'll compile source code, it'll run tests, and it'll produce software packages as an output. It scales continuously, so you don't have to manage that, and you leave that undifferentiated heavy lifting over to AWS. You can create custom build environments suited to your needs. Just bring in Docker images to go through and do that. And if you have something already, so your existing build tools, you can containerize those and bring that into code build. You only pay by the minute. So as with all the other AWS services, it's based on paying for what you use. Right? You don't have to go and commit to 1 year of code build and anything. So it's just, you need it for 10 minutes, you run it for 10 minutes, you pay for 10 minutes. And it also has Jenkins integration, which is important. I know a lot of people are using Jenkins today, so it's not a binary choice, one or the other. Jenkins still works with a lot of our code services, and we have thousands and thousands of customers using Jenkins and using our individual AWS code services to integrate with it. So how does it work? First thing we'll go through and do, download the source code. It'll execute commands that are configured in a build spec in temporary compute containers. It'll stream all of the output to the console and Amazon CloudWatch logs, and then it'll take the generated artifacts and put those up into an S3 bucket. You can go through and use it with Code Pipeline for your CI/CD pipeline. You can plug it into multiple other features and services, whether or not they're AWS. I talked about Jenkins. It has a full-featured API, CLI-driven. If you already have your own build environments, I mentioned you can bring those in and Docker images, and then the Jenkins plugins that exist for it as well. If we take a look at the build spec file, which hopefully is showing up okay here on the screen, the individual pieces as you go and build out a build, this is a YAML file for code build. Up here at the top, individual variables that can be used at the various phases of the build. So here we're setting an environment variable, and then down in the individual phases, we have an install, pre-build, build, and then the post-build steps we'll do in the artifacts. So you can go through here, you see we're doing an apt-get installing Maven. In the pre-build stage, we're not doing anything, we're just echoing out some information here. In the build phase, we're actually going to go through, do the Maven piece, Post-build, nothing we're doing in this example. And then the artifact, we specify that we want it to be a zip file, and it's going to be outputted to that S3 bucket, target, and then what you're going to do at the end. We have hundreds of samples available online in our GitHub repos and the documentation, so you don't have to start from scratch with those files. You can go through the documentation or pull down samples, community sourced up in a AWS Labs GitHub repo to show what other people are doing and examples that we have. But in a lot of cases, you have a pipeline or a process that you want to go and custom develop. So when you look at building your code, that typically refers to the languages that require compiled binaries, right? Java, JVM, the .NET languages. We also refer to the process of creating Docker container images as building the image. So again, where we look at those differences of the CI/CD pipeline for development and the CI/CD pipeline for infrastructure as code, see a lot of those parallels and similarities. The things that don't require building, so you might not need a code build for, PHP, Ruby, Python, Node, interpreted languages. You just go and deploy your code. So let's talk about testing your code for a little bit. Testing is it's definitely a science and it's an art form. My first career, I cooked for a living. I went to culinary school, I was a chef, and it was great. It burned me out in like 3 years. But I kind of think of it as the same thing. Like there's definitely an art to cooking, but there's a science too, right? The heat and the chemistry that goes along with it. Testing your code is very similar, right? There's an art form to it. Goals for testing your code, you want to make sure that it's doing what you're intending, right? When you write that code, you want to make sure it's actually doing what's intended. You want to, if you're catching syntax errors, code patterns, you want to make sure that tabbing or spaces is at a, whether it's a standard for the application language you're using or internally what your company or institution or standards are. And then you also want to look at making the applications more secure in the testing phase. Where you generally are going to focus your tests, unit testing is about 70% here, service and then UI up at the top. You look at the AWS services and where that relates, AWS Code Build is down here in the unit testing part and build process, and then up top, third-party tooling. So if you have existing third-party tooling, you can go through and use that. And then finally, the pricing for Code Build, you can go through here, see general 1.small, 2 CPUs, 3 gigs of RAM, and it's half a penny per minute. The free tier has 100 free build minutes. So if you left today and you had an AWS account and you wanted to go through and try this, you could build something for over an hour and won't incur any charges in the free tier. So now let's look at deploying your applications. So this is where AWS CodeDeploy comes in. It automates the code deployment to any of your instances. You can go through, add a lot of complexity to, remove the complexity of updating your applications, and also look to remove downtime. CodeDeploy will go through and do an automatic rollback if there's a failure detected. And then you can use it not just for your EC2 instances running in AWS, but you can do this for your on-prem servers or other cloud providers if you even want to go through and do that. And it integrates with a host of third-party tools and other AWS services. This is the appspec.yaml file that you'll go through and look and see for CodeDeploy. What we have here, the individual pieces. So it supports multiple operating systems. You see up top, we have Linux here. The source and destination, where we're going to take the application files in one directory or other configuration files. In this example, we're going to do some stuff with Apache. We look at the specific permissions that you can define on those files. And then down at the bottom under hooks, what the application does, how to stop it, before install, how to start the application, and then to go through and validate the service. And you'll see most of these here are shell scripts that have been developed. Again, looking online in the AWS documentation and our AWS samples, AWS Labs, GitHub repos, tons of examples on how to go through and do these things. You can choose how you want to have CodeDeploy go and deploy your applications. So you can do it one at a time. You can go through and do half at a time, or you can do it all at once. Generally, all at once, some people will generally ask like, well, would I ever do all at once to my production environments? And there are definitely use cases where people will go through and do that. Depending on the uptime or availability, you can go through and just deploy it all at once. Or if you're doing blue-green deployments, if you're deploying to a new application and then switching a load balancer from the old to the new, it's a valid use case for all at once. But you have lots of choices that you can go through and do here. And then you can enable rollback or just blow through. So if you go through and it fails, you don't have to go through and do a rollback. So now orchestrating all of this build and deployment with a pipeline. This is what AWS Code Pipeline is going to do for you. It's a continuous delivery service, fast and reliable application updates. It also allows you to go and model and visualize this. So I'll show an example where you can actually see what that deployment process looks like. And it integrates with, again, third-party tools, AWS. If you went in the code pipeline console and set up a pipeline, you'd see something very similar to this. Starting off, sample my application. We have the source listed here as GitHub. That could be code commit, different other options. In the build process, that's code build. So we're listing out AWS code build here. And then the deploy part, that's the Java application, and we're going to deploy this into AWS Elastic Beanstalk. But this could be any number of different targets that you want to go through. This is the pipeline. These individual boxes and blocks are referred to as stages. So here in the middle is the build stage. Underneath the blocks, the smaller pieces, that's the action that you're going to do in that stage. The arrows point to a transition going from one stage to the next. In the individual stages, you can do multiple parallel actions. So in this example, we're kicking off code build and then we're going to fire off a Lambda that's going to go and notify our developers. You can also go through and do sequential actions. So I do those two parallel actions in the first piece, and then after that, I'll go through and run a test API to make sure everything's good. Moving on, this shifts up a little. We see the builds at the top now. We have another stage here. It's called staging deploy. The QA team review, this is a manual approval. So you can go and introduce, using Code Pipeline, a manual approval process. So that could be a QA team needs to go and review it. It could be change management. It could just be a sanity check that you want to go and just check one more time before you go and deploy. And then finally, the deployment piece here at the end. Now let's talk a little bit about code commit. Code commit's a secure, scalable, managed Git source control. Uses the standard Git tools that you're already familiar with. It uses S3 on the back end to store it, so you get that same scalability, availability, and durability of Amazon S3. If you're not familiar with S3 or a simple storage service, that has 11 nines of durability. So when you store an object in a region into S3, we copy it to 3 separate availability zones. Those 11 nines of durability, what that means is, I get the numbers mixed up sometimes, but the math essentially works out to be if you stored 10 million objects over 10,000 years, the possible incurred loss of one object. It's pretty high. 11 nines is pretty high level of durability. And at 2.3 cents per gigabyte in the US regions, the cost point is great. I mean, $23 to durably store a terabyte of data. That's pretty amazing. Most of our services are using S3 in the back end in some capacity. AWS Code Commit is actually storing those artifacts in S3. You can use encryption and REST using your customer provided keys, and there's no repo size that you have to worry about. And then it ties in with all the other AWS services such as SNS for the simple notification service or Lambda. Using source control in the cloud has a lot of added benefits here. So you can go through, get that same security in the AWS cloud that you're getting with the other services, your applications, and your servers. You can go through and look at a service called AWS Artifact. It's in the console, and it lists out all the SOC reports and everything that we go through in terms of governance and compliance. And you can go through and down those and look at those and which services are and aren't covered. FedRAMP, all of these things, it's available in the console and on our website. It's a fully managed service, so you don't have to worry about patching servers or scaling. We just take care of all of that on the back end. It's highly available. Durability we talked about already. What code commit looks like, essentially, this diagram here, You see a git pull or push coming from a source with a laptop or whatever workstation you're using. It's going over an encrypted channel. You can configure it to be SSH or HTTPS. Goes into AWS Code Commit. Those objects are stored in S3. We're using Amazon DynamoDB. It's a NoSQL database to store the Git index. And then we're using encryption keys in the AWS, so you can use your own provided keys using AWS KMS. It's gonna be the same Git experience that you're used to today. So here in this example, we're gonna go and clone this repo. It's gonna pull it down. We're gonna open up the README file, make some changes, and then we're gonna do a commit. Same Git process you're doing today, and then push. You see here, I mean, it's no different on what that source target using code commit's gonna be. The pricing for these individual services, so code commit, that's $1 per active user per month. And your first 5 users are free. So if you have in your AWS account 1 user, your repo, it's $1. Code pipeline, it's $1 per active pipeline per month. So 10 applications using 10 pipelines, you're gonna pay $10 per month. Code deploy, this is actually free. We want you to deploy your code in AWS, it's free. And so if you're going to EC2 instances, it'll be free. If you're going to on-prem servers, it's 2 cents per update to those on-premises servers. And then code build down at the bottom, we went through the pricing here. So you can see getting started and building out this pipeline is fairly inexpensive. And then there's also free tiers for a lot of these services. So if you're not familiar with it and you're just getting started off and you're playing around, you can build EC2 instances. There's a free tier for those, 750 hours for certain instance types that you can go through and build a mock proof of concept or a working environment. And then as you scale out, it's very inexpensive to keep rolling with it. Next, I'm gonna talk about AWS CodeStar. This is a service that allows you to go quickly develop, build, and deploy an application on AWS. You can get going in minutes. You can set it up across multiple teams, and you can manage software directly out of it. This is a great service. If you wanted to go and figure out in the last 30 slides that I just ran through how to get all of that set up quickly, go into CodeStar. You can get up and running in minutes, and you can get a pipeline going, it'll do the repository, all those individual features that you need, and then you pick the language or template that you want to get started off with. So here, going in the CodeStar console, we can see there's a bunch of different application templates that we have. So there's Node, Ruby, Python, countless others I can't even fit all on the screen here. And you scroll through and find the application or framework that you want to go and start off with. After you select that template, you go through and set your source control provider. So if you're using GitHub today, you can still use GitHub. You don't have to use code commit. We're not gonna tie you in and lock you into having to use that. If you like GitHub, keep using GitHub. From there, after you select your template and your source provider, you're gonna look at the continuous delivery toolchain that we have set up. So you can go through, we have a bunch set up here already that you can go through and use. In this example, we're doing a Node.js example. It's gonna use code build for some of the testing, deploy using CloudFormation, and then on the end in the environment, it's gonna be running out of AWS Lambda, and monitoring is gonna happen in CloudWatch. So again, the last 20 slides, we just distilled down to this 2 pieces in this application here in CodeStar. It also allows you to go and connect your favorite IDEs. So if you're using Eclipse today or Visual Studio, or you're looking at AWS Cloud9, which I'll talk about a little bit later, you can go and just do this right out of CodeStar. And then you can set up team access. So if you have multiple developers in a team or multiple teams going through and working, you can go through and set up through identity and access management, add team members, send them email invites, and then set the access level. So they might just be a viewer, or they could potentially be a contributor or an owner. CodeStar is a unified dashboard. So you can go through and look at the individual projects and then do and hook in your components that you have. In this dashboard, you can also see the CloudWatch logs coming up. So in this example here, we're showing CPU utilization on this individual application. Not sure what the little weird black things that are coming up on the slide here are. That has nothing to do with the console. So we'll talk about AWS X-Ray now. X-Ray is really about debugging your application running in AWS. So if you look back at the way developers traditionally are going to be doing debugging, you have your developers going to run some local tests. That's going to output some logs. Then they're going to go back, developers going to look at them, they're going to add in some breakpoints, add in some log statements, go back in, do more local testing, circle of life continues. This workflow looks monolithic. When you move over to a service-oriented architecture or microservices, it becomes a bit more difficult to go through and do this. That traditional process of debugging just doesn't really scale well. Like I said, it's tedious, it's repetitive, it's time-consuming. And it also requires individual siloed teams or DevOps teams to spend more time debugging. This is where X-Ray comes in to help. So you can go through and use X-Ray to identify performance bottlenecks, which is really nice. So if you have message passing through your application and you see that it's running slow, you can use X-Ray to figure out what that is. Individual services, maybe it's the databases, the slow response time. Anybody that's gone through and debugged an application and you get a user complaint, it's slow, that could be any number of things in your systems, your applications. X-Ray has a dashboard where you can go in and actually look and see, there's a nice red dot that says, it's this piece of code, it's this application component. It'll also allow you to identify errors. Some additional use cases for X-Ray. You can use it off cloud as well, so you don't have to be using it solely within AWS. You can do filter expressions, you can set up custom apps and APIs, tons of different things that you can do with X-Ray. Looking at the service in a little bit more detail, see the trace request. We start off over here on the left. So X-Ray starts off, it collects this data about each of the underlying applications and services that pass through. It then goes and records these traces, and then you can view a service map in the AWS console. So you can see the red and green pieces here that we're talking about here. So over on the right, where we go and analyze issues, we can actually see here it's talking about the traces that it's run and with the average time of 0 to 15 milliseconds, and calls out individual components and pieces where there's problems. The workflow for X-Ray starts here. So whether you're running on premises or in AWS, you have your DevOps team that's looking or working in the console through the X-Ray API. There's your applications that are going to plug in and use the X-Ray SDK. If you're running in AWS on EC2 instances, you're going to use an EC2 role, and then the X-Ray daemon is going to be taking and grabbing that information that's coming out. So in your code, you're putting pieces of X-Ray components in the SDK in there. On premises, similar workflow. Instead of using an EC2 role, you would have to use AWS credentials. So you would go through for your on-premises servers, use those credentials, tie that in, and then it's uploaded into the X-Ray API. Multiple SDKs available for it, and this is growing over time. If there's an application language that you are using that is not listed up here, please let me know. One of the things that we do continually at AWS, whether it's the solution architects or the developers, the software management, continuous feedback we want. So I talked about those 1,800 meaningful features and releases that we put through last year. 90% of our roadmap comes from you. So when customers have problems or features, things they love, things they hate, we want to know about that because we're going to go through and roll those features out really quickly. And you can see this over the history of time, right? A service like AWS Lambda started off with Node.js, I believe was the first language, and then quickly to Java, and then more languages, Python after that, now to a whole host of services. So don't get too discouraged if your favorite programming language isn't up here on the list. It could be, but you have to let us know. We want to know about those features, the things that are important to you. You can go through, use non-AWS services with this as well. I talked a little bit about that. Multiple database platforms are supported. And then queuing, right? So if you're using SQS, you can hook and use that in for the monitoring and trace analysis. The source for this is up on GitHub. You can go and check it out. The daemon, this is actually receiving the data from the SDKs that you're putting in your applications over to UDP. It's sitting there taking all this information in, and then it's acting as a local buffer. That data is flushed every second or when the buffer is full. So that's the intake engine that's going to sit there continually getting all your trace information and putting that up into X-Ray service. It's available today on Linux, Red Hat, Mac, Ubuntu, and Windows. And again, if your favorite operating system isn't there, let us know. Looks like we still have 10 more minutes. The guy next door got done a little bit early, so bear with me here. You can also go through, use your AWS credentials in here, so the identity access management pieces, or if you're running in AWS, again, using roles. All of this, again, is available up on GitHub. Here's a list of helpful links. All of these talks and presentations are going to be available on YouTube in the next couple of weeks, so the email you use to register with, we'll send out a notification to let you know, so everybody doesn't have to scramble to try to get all these links. Last service I'm going to talk about today is AWS Cloud9. This is actually one of my favorite new services that we have at AWS. It is a cloud-based IDE. So instead of having to go through and install Visual Studio or any of the tools that you go through and use, you go to the AWS console. I think it's aws.amazon.com/cloud9. Log in, you create an environment, and you're ready to go. It's a fully featured online, through your browser IDE. And this is great. So that whole process where you have to go through as a developer and get your developer environment set up on your laptop, you can now just do this natively in AWS and use that IDE. Gives you direct terminal access as well. So what happens under the hood for Cloud9, it's going to spin up an EC2 instance for you, and it's going to be pre-configured with a role that you can go and run AWS CLI commands off of. And then that IDE will integrate directly in with it. It's also really good for serverless. So if you're building a serverless application, that whole ecosystem is built right into Cloud9. Taking a look at what the IDE looks like, different themes and skins that you can go through. So if you like the dark background, you can go through and change it to like the matrix theme. It has color context highlighting for the individual languages that you're going to go through and pick. You can do multiple panels. Code completion and hints will also come up as well. Most standard popular programming languages are going to be available for this, for the code autocomplete. The broad selection of runtimes that you can go through and run. So here in the IDE, see, we're going to write some code and then we're going to run, and we're going to pick one of the individual runtimes to go through with. Has a fully featured debugger that you can go through and use as well. So traditional things you do in your IDE, like setting breakpoints, debug controls, you can do all of that here within Cloud9. And this is really helpful for even if you're not a developer, maybe you're an infrastructure person and you're looking to get into Python and you want to use a service like AWS Config that runs Lambda. Take that and do it in Cloud9. You can actually go through and debug your Python scripts in Lambda using Cloud9. And it makes your life so much easier to go through and use this. It also has the integrated tools for serverless development that I talked about. So here in this example, we can see we're building a serverless application. I have a couple Lambda functions that I'm going to go through here and use, and it's also integrating with API Gateway. So I can do a local test on my Cloud9 environment and then deploy it into my AWS account or accounts for production. So if we take a look through all of this that we put together today, what continuous delivery for a serverless application is going to look like. So we'll see here, if we're using CodeStar and we want to go through, set all of that up, it's going to help us build the AWS code pipeline. We're going to author this in Cloud9. We're going to use our source repository, again, whether that's code commit or GitHub or whatever you want to go through and use. That build process, using AWS code build, and then that deployment into Lambda. Going into CodeStar and Cloud9 is going to allow you to do this within minutes to build an entirely serverless application. And again, in the AWS samples, GitHub repo, and the AWS labs, dozens and dozens of test environments and applications that you can go through and set up and build. And then the continuous delivery for containers is going to look very similar to this. So again, we'll have code pipeline is doing the orchestration piece here. We're going to have a source code repository that's going to be code commit or GitHub. Our build process, that could be code build or it could be Jenkins. They integrate and they work together. Jenkins has tons of plugins, so you can go through and use it for that. Then the artifact that are going to come out of this, you're going to stand this into Amazon ECR. This is our container registry. So instead of using Docker Hub, for example, you can go and use this with an ECR. The benefit of using ECR for your container registry is you can put it in your AWS account. Same thing with code commit, right here in the source product. It is tied to your AWS account, and you can do a hook into your VPC so your code or your container or your images aren't going out over the internet to third parties. They're staying in your AWS ecosystem environment and they're not leaving. And then from there, you can go through and deploy into ECS or EKS. This is what a continuous delivery for containers looks like. if this is something you're interested in, there's a serverless talk later today. It's going to be up here. And then there's also a continuous delivery for containers talk, and I think it's at 2 p.m. today. Look on the app. They change it time to time. One of our solution architects takes this slide basically and breaks it down into an entire talk. So if this is something of interest for you, highly recommend that you go and check it out. And with that, I'd like to thank everyone for coming in and listening to all this. We can't do Q&A because of the silent disco, so I'm going to be out there after this. If anybody has questions they want to come up and ask, please complete the session surveys. We really take the information to heart. We want to know the things you love and the things you don't. So again, thank you, everyone.